What if the universe you see, the ground you walk on, even your own memories, were no more real than the pixels on your phone's screen? The idea that we might be living in a simulation isn't just a plot twist for science fiction. It's a real question, debated by physicists, philosophers, and technologists alike. If you've ever wondered whether reality is what it seems, you're not alone. Let's begin with an old puzzle, one posed almost 2,000 years ago. Once upon a dream, I was a butterfly. Now I wonder, am I a man who dreamt I was a butterfly, or a butterfly now dreaming I am a man? That's from the philosopher Zhuangzi. The question forces us to consider how we know what's truly real. Are our senses reliable? Or could reality itself be just a kind of dream? Fast forward to the present. This question takes a high-tech twist with what's called the simulation hypothesis. The theory goes like this: if computing power keeps increasing and virtual worlds become indistinguishable from physical reality, maybe one day intelligent beings, human or otherwise, would run simulations of entire universes, complete with conscious beings inside them. And if these simulated realities vastly outnumber base reality, the odds tilt in favor of us being simulated ourselves. It sounds wild, but some find the logic compelling. Philosopher Nick Bostrom is famous for popularizing this concept. Paraphrased, he argued, if it's possible to simulate minds, and if such simulations are common, then statistically, you're probably inside one. Now, that doesn't prove we're in a simulation. It just makes it a possibility we can't dismiss outright. But how would you know if you're in a simulation? Would there be any signs, glitches, bugs, or limitations, just like in a video game? Here's where physics comes in. Our universe, as we've observed it so far, has fundamental constants, hidden rules, and underlying structures that just might, in theory, give away the game. One example: consider the limits of computation itself. In a computer simulation, everything is ultimately processed by bits, discrete chunks of data that represent reality in on-off states. Now, the universe itself seems to have built-in limits. The Planck length, the smallest possible measurable length, the speed of light, the ultimate speed limit, energy quantized in discrete packets. These pixelated features of reality have led some to wonder if they're resolution limits imposed by a simulation's hardware. Here's something physics tells us: when you look deeply enough into reality, it gets fuzzy, granular, not infinitely smooth. Quantum mechanics is full of strange uncertainties. You can't know both the position and momentum of a particle perfectly. Sometimes things just don't exist in definite states until you look at them. Is that just how natural reality works? Or is it the kind of shortcut you'd expect from a simulator, allocating resources only when you're observing closely? These questions echo a passage from The Matrix, where Morpheus says, "What is real? How do you define real? If you're talking about what you can feel, what you can smell, what you can taste and see, then real is simply electrical signals interpreted by your brain." This isn't just movie philosophy. Neuroscience agrees. Our perceptions are always filtered through brains that operate like information processors. If you're living in a simulation, the line between experience and code becomes tough to draw. Let's reflect. Even if the universe behaves like it's made of digital bits and fundamental limits, does that prove we're not in base reality? Could what we call natural laws just be the rules of some cosmic operating system? Or maybe that's just how reality happens to be, whether simulated or truly real. Some physicists believe if the universe were a simulation, there might be telltale patterns. For instance, If the grid underlying the universe were coarse enough, we might find small anomalies, like unexpected limits in the energy of cosmic rays, or subtle asymmetries in the way particles behave. So far, no hard evidence of such patterns has been found, but the search continues as telescopes and particle detectors look for subtle clues. But is the simulation hypothesis really testable? Here's where the question gets slippery. If a simulation were perfect, so perfect that no internal observer could ever tell, they'd have no way to prove or disprove it from the inside. In philosophy, this is called an unfalsifiable theory. It can't be conclusively proved wrong, nor undeniably proved right, from within its own system. Yet, the hypothesis also invites us to look carefully at the coincidences and oddities around us. Why is our universe fine-tuned for life? Why do the laws of physics appear mathematically elegant, sometimes even beautiful? Some suggest a simulator might dial in the universe to produce observers like us, perhaps running billions of simulations to see which ones work out. This speculation brings to mind lines from Shakespeare. All the world's a stage, and all the men and women merely players. They have their exits and their entrances. If we're players in a cosmic play, what does that say about our choices, our hopes, our meaning? Reflection time. Just because something is possible doesn't mean it's true. The simulation hypothesis is a fascinating lens to examine our existence through, but it doesn't negate the value or realness of experience. Whether the universe is fundamental or simulated, what we feel, think, and do, all still matter. One thought experiment pushes even deeper. If future beings or civilizations can run countless simulations, and if those simulations include beings with conscious experience, how would the simulated beings know if they were real? The very act of questioning, of doubting, is itself a sign of intelligence. As humans, we think, doubt, and wonder. Maybe that's proof enough that, at least for us, lived experience is authentic, whether simulated or not. Let's circle back to the language of physics. Some researchers have tried to frame the laws of nature as computer code, searching for ways quantum processes could be computed on a gigantic cosmic computer. For example, trying to model space-time as a vast cosmic lattice. That is, a grid of points, like the pixels on a screen. In this line of thinking, our continuous perceptions, flowing space, seamless time, could actually be stitched together from imperceptibly tiny jumps and stops. But that leads to further questions. If there's a server processing all this, where is it? Who or what is the programmer? Are these even scientific questions, or do they cross into the realm of philosophy and faith? Every time humanity develops more powerful computers, advances in virtual reality, artificial intelligence, and digital worlds, it reopens the question of simulation. Just 2 or 3 decades ago, the idea seemed mostly philosophical. Now, with video games gaining ever more realism and AI writing code or painting pictures in moments, imaginative leaps about simulated worlds no longer seem as far-fetched. But before we get lost in digital solipsism, let's pause. Even if the simulation hypothesis is compelling, there's a counterpoint. It might radically overestimate the future of technology. There's no guarantee civilizations survive long enough, or even want to create universe-sized simulations. Plus, simulating a universe with all its detail might require more resources than the universe contains, leading to a paradox. Poets and physicists alike wrestle with such mysteries. Walt Whitman wrote, "I exist as I am, that is enough. If no other in the world be aware, I sit content. One world is aware, and by far the largest to me, and that is myself. Maybe the deepest truth isn't about whether reality is simulated, but about how we live within it, whatever its origin. Then again, if you really want to play with the idea, some have imagined how a simulator might communicate with us. Would a message hidden in math or the cosmic background radiation be the hacker's Easter egg of the cosmos? Or maybe the very laws of physics themselves are the only message. This is all there is. Reflect on this. It's possible that searching for the back door in physics is less about finding code and more about understanding the profound regularity and unpredictability of existence. We may be both the questioners and the questioned, simultaneously part of the system and seekers of an exit. The simulation idea also connects to age-old questions about fate, free will, and choice. If everything is simulated, does that mean it's all predetermined? Playback on a cosmic tape? Or are even the simulators surprised by what unfolds? Can a virtual world have genuine unpredictability? Science and philosophy may not offer a definite answer to whether we're living in a simulation, but that uncertainty, that sense of grand questioning, is the heart of what it means to be sentient. To question, to doubt, to explore. These are not flaws, but features. They're how progress happens, how new truths emerge. So, are we living in a simulation? The only honest answer is, we don't know, maybe can't know. But the fact that we can ask the question and invent experiments to test the nature of reality, that's its own kind of magic. After all, as one old proverb suggests, we see the world not as it is, but as we are. If the simulation is real, so too are our dreams, our discoveries, and our questions. In the end, maybe reality is what you make of it, pixelated or not. And the search for truth never needs to end, as long as there are minds to wonder and universes, simulated or otherwise, to explore.